Here three statements are given and we have to find out which of them are true and which of them are false. Let us see the first statement. In SQL, by default, order by clause lists items in descending order. In SQL, order by clause lists items in ascending order, not in descending order. So statement 1 is false. Let us see the second statement. In SQL, select clause automatically eliminates all duplicates. This is not the case. In order to eliminate duplicates, we have to use select distinct statement. Then only we will be able to eliminate duplicate tuples. So here second statement is also false. Let us come to statement 3. In SQL, the union operation automatically eliminates all duplicates. Yes, union operation is used. If we use union operation, it will automatically eliminate all the duplicate tuples. So here statement 3 is true. So here the correct option would be option C. That is 1 is false, 2 is false and 3 is true. So here the correct option is option C. Here it is given that there are 5 transactions and we have to find the number of valid serial schedules. If there are n transactions, then the number of possible serial schedules would be n factorial. Here n is given as 5. Hence the number of serial schedules would be 5 factorial, which is option 5 factorial, which is nothing but 120. So here correct option is option D. Here the given question is, for any CFG there is a parser that takes at most dash time to parse a string of n tokens. Here we have to fill in the blank with the correct option. For a given CFG, there will be a parser that takes at most order of n cube time to parse a string of n tokens. So here the correct option is option D.
Match the following. There are two lists. List 1 is semantic, syntactic and lexical. List 2 is misspelled keyword, arithmetic expression with unbalanced parenthesis, operator applied to incompatible operand. So here these are generally the phases of the compiler: the lexical phase, semantic and syntactical phase. Usually in the lexical phase, the entire program will be scanned and it will be divided into different tokens. It will find out all the mistakes that are done in typing or some reserved words, keywords, something like that. So the misspelled keywords that are identified in the lexical phase of, it is the first phase of the compilation process. So 3 is related to A and semantic is related to meaning. So here operator applied to incompatible operand, for example. This is not a proper meaning. That's why the semantic is related to the C. And syntax, using the pushdown automata, we used to find out whether this is balanced or unbalanced, whether this arithmetic expression containing parentheses and all. So syntactic is related to arithmetic expression with unbalanced parentheses. Usually it will be implemented through pushdown automata, the syntactic structure. Semantic is the meaning. So this 3 is related to A and 2 is related to B and 1 is related to C. So option D is the right option here. Which of the following statements is /or true? So we need to find out the true statement. Some statements were given. Many processes can simultaneously sleep on an event. Statement S2 is, when a process wakes up, it executes immediately. Statement S3 is, sleeping process can consume CPU resources. Here we should know what is a sleeping process actually. So many processes can simultaneously sleep on an event in the statement S1. It is possible. For example, in a critical section, when the particular semaphore value is 0, then all the processes that are accessing that semaphore will decrement that value and those states will be changed from running state to waiting state so that they will sleep. So they will not consume any CPU resources, because in order to overcome the busy waiting, we need to make that process from running state to waiting state whenever it is trying to get into the critical section but it is unable to go. So many processes can simultaneously sleep on an event is true. It is possible because as many processes as are coming, so all these processes can sleep whenever there is no chance for going into the critical section or somewhere else. So now S2, when a process wakes up, it executes immediately. Normally a sleeping process will be waken up by the some signal operation of the semaphore. So whenever it is waken up, it is going from waiting state to ready state. When a process is in ready state, usually the scheduler will select that process immediately. There is no chance for that, may not be a chance for the execution. That's why when a process wakes up, it executes immediately. Immediately it is not possible because it is based on the scheduler. Sleeping process can consume CPU resources. It is false, because CPU sleeping process cannot consume, because we are making that from running to waiting, so that in order to overcome that problem, busy waiting problem only, we are making that. That's why sleeping process cannot consume the CPU resources. Only statement S1 is correct. Option C is the right option here.
Here we have to match the IP addresses to the classes which they belong to. We can identify the class of the IP address by looking at the first octet. If the first octet ranges from 1 to 126, if the first octet ranges from 1 to 126, then it belongs to class A. If it is ranges from 128 to 191, then it belongs to class B. And if it is from 192 to 223, then it belongs to class C. And if it is from 224 to 239, then it belongs to class D. And if the first octet ranges from 240 to 255, then that IP address belongs to class E. So here, if we see the first IP address, in this address, first octet is 218. So this IP address belongs to class C, 192 to 223. So this IP address belongs to class C. Here the first octet is 238 and this belongs to class D. Here the first octet is 124. This belongs to class A. And here first octet is 139, which belongs to class B. So here the correct option is option A. Here a graph is given and we have to find the sum of degrees of all the vertices. If we observe the graph, there are self loops to certain vertices. Whenever there is a self loop, we have to calculate twice while calculating the degree of that particular vertex. So here the degree of this vertex would be, this self loop is counted twice. So this is 2, this is 1 and this is 1. So here degree of this vertex would be 2 plus 2, 4. For this vertex also the degree would be same, that is 4. Here this for this vertex, this self loop is counted twice. So 2 plus 1 plus 1 plus 1 and plus 1. So here degree would be 2 plus 3, 4, 5, 6. 6. For this vertex, the degree would be 1. And for this vertex, the degree would be 1. So here the sum of degrees of all the vertices would be 4 plus 4 plus 6 plus 1 plus 1, which is equal to 16. So here the correct option is option D.